Welcome to a session on Kronig Penny Model. According to Bohr's theory, the atom can be represented as the central part of the atom is called as nucleus, and around this nucleus electrons revolves in certain paths. Those paths are called as what? Orbitals. Of course, how many orbitals will be there, that depends upon the electronic configuration. Let us take a atom, any atom of any metal. For example, these are the electrons of outermost orbital of a metal. At room temperature, what happens is these outermost orbitals of the metal absorbs the thermal energy and they will come out of from atom. So after coming out of this electron, this atom become what? A positive ion, and of course this electron become what electron? Free electron. This is called as free electron, which is responsible for electrical conduction. If you take out the overall picture of a solid or metal, so each atom after losing the electron, it becomes positive ion. Of course, each and every atom loses electrons. Of course, we have to represent so many number of electrons. Here I represented only single electron. According to classical free electron model and quantum free electron model, the electron, when it roams inside the crystal of which consists of positive ions, it experiences zero potential or constant potential. So based on this assumption, CFE model and QFE model is successful to explain so many facts. For example, how the electricity arises in the metals, origin of electricity and thermal conductivity, as well as it verifies Ohm's law, heat capacities of the solids, as well as they verify the Wiedemann-Franz law. Despite of that success, it is having one of the biggest failures. There are so many failures. In that, one of the biggest failures of the classical free electron model is it cannot distinguish between the conductors, semiconductors and the insulators. For that, we are going to Kronig Penny model. So now in this classical free electron model, the interaction between the electron and positive ions completely neglected, which means there is no interaction between the electrons and the positive ions. So now let us take the crystal which consists of positive ions. Now when the electron is there, if it want to roam inside the crystal, when the electron is approaching positive ion at the site of positive ion, the potential energy according to Coulomb's law is 1 by 4 pi epsilon naught into Q1 Q2 by R. So here in the Kronig Penny model, this potential interaction of the electron and the positive ion are taken into account. So V is equal to 1 by 4 pi epsilon naught into Q1, charge of the nucleus, which is plus Jd, and charge of the electron is what? Minus E, plus Jd into minus E divided by R. So this is the potential of this electron and positive ion system. So V is equal to, as R is, this value of E depends upon what? R. If the electron is in between the two positive ions, or if at a distance r, then it is having certain negative potential. Negative potential. When the electron is at the site of a positive ion, the distance is equal to what? 0. Anything by 0 is equal to what? Infinity. So that is equal to minus infinity means negative high. Negative high. So I can represent this potentials like this. At the site of positive ion, the potential is negative high. At the in between the two positive ions at a distance r, the potential is negative low, which means we can represent the potential like this. So since this is a metal, the atomic structure is regular, so we can shape the potential like this. These are called as a periodic potential. So according to Kronig and Penny, So as the electron moves inside the crystal, this electron experiences the potentials. At some places it experiences a low potential, at some places it experiences a high potential. High potential, low potential, high potential. So if you further simplify this as like this, so this is called as well and this is called as what? Barrier. This is once again well, this is called as what? Barrier. So electron is moving under a one dimensional well of the potential and a barrier of the potential. Okay. So this particular shape of the potential further modified by the Kronig and Penny as like this. So along what is the y-axis? Potential axis, and the height of the potential barrier is V0. Let us assume that this is origin and this is A and this is what? 2A, and this is minus A and this is what? Minus 2A. So which means that the distance between positive ion to positive ion. So one positive ion is here, another positive ion is here. The distance between these two is represented as what? A. In between them, the potentials are represented like this. Actually, this is also well, and this is what? Square. So that's why this is called as a square well potential. What is the difference between the previous shape of the potential to this potential? There, somewhat we have taken the potentials in the form of a sine wave. Here, the shape of the square potential experienced by the electron is taken in the form of square wells. Why? Why the Kronig Penny changed the shape of the potential means to make mathematical simpler much easier. So this is one of the change they did. So electron, now the electron moving under these potentials. So electron moving under two regions continuously. Region number 1, region number 2. So this is well, this is square. Once again, this is what well, this is what square. So electron moving under a square well potentials. Of course, it is also periodic potential. Now to find out the energy values of the electron and the wave functions of the electron when it is moving under a potential period, of course periodic potential, we have to apply Schrodinger's time independent wave equation. So now let us apply d square psi by dx square plus 8 phi square m by h square into e minus v of x into psi equal to 0. This is the Schrodinger's time independent wave equation which I am applying for this electron which is moving under a square well potential or periodic potentials. The solution of this wave equation can be assumed as psi of x equal to uk of x into e power ik of x according to Bloch's theorem. So a Bloch scientist proposed this is the shape of the wave function, which means that according to de Broglie hypothesis, as the electron moves in a periodic potential, of course when it is in motion it acts like what? A wave. It behaves like a wave. The shape of the wave is this, uk of x into e power ik of x. So this is the wave function, solution of the wave function taken by the Bloch. So first thing. The second thing is to further simplify the mathematical equations. Kronig and Penny assumed that psi and d psi by dx are continuous functions. Continuous functions. Why they made this assumption? Why? Because at any point, for example, you take this point. At this point, if you take psi and if you multiply this with what? Psi star, you would get what? Mod psi square, which will use the probability density function at that point, which means that the chance of finding the electron in this region. So at any region in the crystal, so the psi value should not be 0, which means that it should not be abrupt. There should be certain value of mod psi square to find out the probability of the electron. So this is the first assumption made by the Kronig Penny to make mathematical much more simpler. And the second assumption they made is V naught into W is equal to constant. What is this V naught into W? Where V naught is the height of the potential barrier and W is the width of the potential barrier. So the product V naught into W is equal to constant. By taking this solution, and there are two particular special conditions like psi and dc by dx continuous functions and V naught into W is equal to constant, they arrived to the following equation. It leads to the following equation. So what is that equation? P sin alpha A by alpha A plus cos alpha A is equal to cos Ka. So this equation, this is the wave function, this is the condition of the wave function. By substituting those two boundary conditions, what I can say, V naught into W is equal to constant as well as psi and dc by dx, and by taking the Bloch solution, which means Bloch wave function, so the wave function turned out to be this equation. So finally you have a question from this equation. What we do? So we try to find out the value of alpha A from this equation. So how to do it? For this, what we have to do is plot a graph. So what is the equation? P sin alpha A by alpha A plus cos alpha A is equal to cos Ka. This is the condition of the wave function, which are we going to take for t is equal to 3 pi by 2. So now in this equation, of course, this is LHS, this is RHS. RHS is cos Ka, it's a pure cos term which is restricted between +1 and -1, which means that RHS purely restricted between +1 and -1. So here I am taking +1 and I am taking -1. So LHS, RHS is restricted between +1 and -1. Now what I am doing is I am drawing a graph between P sin alpha A, P sin alpha A by alpha A plus cos alpha A versus alpha A, versus alpha A is taken along the x-axis, and P sin alpha A by alpha A plus cos alpha A is taken along the y-axis. You may ask, what is this P? Here P value is 4 pi square m A by h square into V naught into W. 4 pi square MA by h square into V naught into W. Here P is called as scattering power. Scattering power of potential barrier. What does it mean? It means very simple. As P value becomes very less, there is no interaction between the electron and the positive ion. As P value becomes very high, there is a huge attraction between the negative electron and the positive ion. So the electron is solely bonded to that particular ion. So that become bonded case. Okay, this is P value. And here what is alpha in this equation? The value of alpha is equal to 2 pi by h into root 2 me, which represents the energy. If you clearly indicates what alpha indicates is energy. So these energy values are taken along what axis? X-axis. Because of that, alpha A is taken along the x-axis, and P sin alpha A by alpha A plus cos alpha A is taken along the y-axis. For the value of P, here P is equal to not high, not low. It is moderate value. P is equal to, for P is equal to 3 pi by 2. Now I am going to draw the graph. So this is pretty much similar to diffraction pattern of a double slit diffraction pattern. So this is the central maximum, this is first order diffraction maxima, so on. Of course, here also this is the diffraction pattern of the electron wave which is diffracted at various positive ions. So of course, coming to the point, here alpha A, x-axis is restricted between +1 and -1. Since in this wave mechanical solution, only the part which is in between +1 and -1 is allowed. This part of the solution of the wave equation is not allowed because it is beyond -1. Once again, the solution in this wave mechanical solution, this part of the curve which is between -1 to +1 is allowed. Once again, this part of the curve is also allowed. Similarly, we can draw to the left hand side also. So, if you clearly observe this, the first point, the conclusion 1 is this. First conclusion is the wave mechanical solution permits in between -1 to +1. Between this is a +1 and a -1. The wave mechanical solution, the permitted value of wave mechanical solution, which means in between +1 and -1, forms allowed energy bands. These are called as what? Allowed energy bands. This one, and this one. These are called as what? Allowed energy bands. Of course, in between two allowed energy bands, this empty space is there. This is called as what? Forbidden energy gap. This one. This is also called as what? Forbidden energy gap. So this is the first conclusion. When we draw the graph between alpha A versus P sin alpha A by alpha A plus cos alpha A, the wave mechanical solution which exists between +1 and -1 forms allowed energy bands and which are separated by forbidden energy bands. This is the first point. And here obvious conclusion is, as the electron moving under a periodic potentials, it is separated by allowed energy bands and forbidden energy bands, which means that as the electron moving in periodic potential, electron don't have all the values of energy, so its energy values are restricted. It should have only particular values of energy only. These are allowed energy values of electron. Next conclusion is, conclusion number 2 is, as alpha A value increases, as the energy value of the electron increases, the allowed energy bandwidth increases. As alpha A value increases, the allowed energy bandwidth increases. At the same time, the forbidden energy bandwidth decreases. This is the second conclusion. The third conclusion is, we will look for p value. So what happens to p value? So what happens to p value? So I already told you that this P is called as scattering power of the potential barrier, which tells us the interaction between the negative electron and the positive ion. If this interaction is high, it's not too high, not too low, high, just high. So then what happens? So this is of course +1 and this is what? -1. As the p value is very high, the wave mechanical solution crossing this +1 and -1 very steeply, so that the allowed energy band become very narrow. So as p value becomes, the allowed energy bands become what? Very narrow. So this is the case when p tends to high, scattering power of the potential barrier becomes high. The next case is, as p tends to infinitely high, not little bit high, infinitely very high. As p tends to infinite, what happens? This is alpha A. Of course, this is P sin alpha A by alpha A plus cos alpha A. This solution, this wave mechanical solution, crossing this plus 1 and this minus 1 almost vertically. So the allowed energy band, which we have seen in the previous case, now become what? A discrete energy level, a single energy level. So this is the conclusion. P tends to infinity. This is the case when P tends to infinity. When P tends to 0, of course it is the last case. If there is no interaction between the electron and the positive ion, which means that P term becomes 0, which means that cos alpha A is equal to cos Ka. Of course, alpha A is equal to Ka. Of course, alpha is equal to K. So, or K is equal to alpha. Then K square is equal to alpha square. So, K square is equal to, what is the value of alpha? It is 2 pi by h into root over 2 me whole square. So, K square is equal to 4 pi square by h square into 2 me. So K square is equal to 4 pi square. You can write it as 4 2s are what? 8 pi square me by h square. So the energy of the electron E is equal to h square K square by 8 pi square m. So here energy of the electron further can be written as h square by 8 pi square m. K is equal to 2 pi by lambda, where K is equal to 2 pi by lambda whole square, propagation constant, K as 2 pi by lambda is. So E is equal to h square by 8 pi square m into 4 pi square by lambda square. We can substitute 8 pi square m into 4 pi square. We can substitute lambda as h by p according to the Broglie hypothesis. So electron behaves like a wave. It is associated with whose wavelength lambda is equal to h by p. So that equation turns out to h square by 8 pi square m into 4 pi square divided by h square into p square. So this leads to E equal to h square by 8 pi square m into 4 pi, of course this is 4 pi square, this is 4 pi square by h square into, what is the value of this? P square. P is equal to momentum of the electron, which means P is equal to mv, that already we know. P is equal to m into v, mass into velocity of the electron is equal to momentum. So here, what are all the cancelling the term? Which terms are getting cancelled? 4 1s, 4 2s, 5 square, E is equal to h square cancel. So what else? M square v square by 2 into m. Once again, this m is cancelled out. So he is equal to half m v square. So quite straightforward conclusion. The electron solely moving with kinetic energy. There is no involvement of water potential energy. When potential energy concept will come in this case, if there is a attraction between positive ion and a negative electron, then V is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R. Since there is no attraction between those two, purely the electron moving with its kinetic energy. That electron is called as what electron? Free electron. So it is quite clear, as P tends to 0, the electron is called as a free electron. For a free electron, so the wave mechanical solution doesn't cross +1 and -1. All the values are in between +1 and -1, which means that the electron have all possible values of energy. Electron can have any value of energy if P tends to 0. So as P tends to infinitely high, its energy, allowed energy value become what? Single energy level, discrete energy level. So this is the Kronig Penny model which explains the formation of energy bands in solids, and it also discusses the behavior of the electron in the periodic potential. Thank you.